All right, so today we're going to be doing lecture 25, multi-step inequalities. So we looked at inequalities last time, but we were doing one-step problems. And today we're going to do them where they have multiple steps. So let's take a look at the first one from the notes. I've got 5x plus 10x is less than negative 30. So for this one, notice that you have two terms on the left side. They both end with an x. So if they both end with an x, they are called like terms. And I'm going to underline them. And I can put them together. So 5x plus 10x, you basically just add the numbers out in front. You get 15x. And the left side becomes 15x. And the right side stays the same. So what I'm going to do now to get rid of the 15 is I'm going to divide both sides by 15. That way, the 15s cancel out. And I'm only left with x on the left side. I bring down the less than symbol. And then over here, I have negative 30 divided by 15. That's going to give me negative 2. So this is going to be the answer. X is less than negative 2. I don't need to flip the sign because I'm not dividing by a negative number. I'm dividing by a positive 15. So there's no need to flip the sign for this one. I do need to write out my solution set. That's going to be all the real numbers x, such that x is less than negative 2. So I always put my variable on the left side and then my answer that I get on the right side of this vertical line. So for the number line, what I'm going to do is I'm going to take the answer that I got, this number, and I'm going to put it in the middle. All the numbers that are less than negative 2, like negative 3 and negative 4, are going to go on the left-hand side. All the numbers that are greater than negative 2, like negative 1 and 0, are going to go on the right-hand side. Now, because I have a less than symbol, I'm going to need an open circle or an open dot on the negative 2. So I'm going to put this open circle right here over the negative 2. And this is pointing to the left. The sign is. So what I'm going to do is I'm going to shade to the left. So I can get all the numbers that are less than negative 2. And then shade the left arrow, whichever direction you're going. Okay, let's try number 2. Number 2 is done the same way, just different numbers. We're going to have 2x plus 7 minus 5x is less than or equal to 4. So for this one, notice that we have x terms on the left side that we can add together. Both of these terms end with an x, so they are like terms. We can put them together. 2x minus 5x is going to give me negative 3x. And everything else is going to stay the same for now. So I'm still going to have the plus 7 the less than or equal to, and the 4 on the other side. So now what I want to do is I want to get the x by itself on the left side, but there are two numbers in the way. I need to get rid of the +7 first, and then get rid of the -3. I can get rid of the +7 by subtracting 7 from both sides. When I do that, the 7 and the -7 will cancel out, leaving me with a -3x that I can bring down. On the other side, I have 4 minus 7. 4 minus 7, you've got a smaller number minus a bigger number. That's going to give you a -3. So now the only thing I have left to do is get rid of this -3 that's in front of the x. And since we're multiplying them together, I'm going to do the opposite. We're going to divide both sides by the -3. So when I do that, the -3 and the -3 are going to cancel each other out, leaving me with x. Since I'm dividing by a -3, I have to flip this sign here. So instead of being a less than or equal to, it's going to be a greater than or equal to. Over here, I have -3 divided by -3. That's going to give me a +1. So actually, they do cancel out, since I have the same thing on the top and the bottom. So when they cancel out, they give me a +1 for my answer. So my solution set, I'll put over here. It's going to be all the real numbers x, such that x is greater than or equal to a +1. So x can either be equal to 1, or it would have to be greater than 1. So we're going to be shading to the right. Not only are we going to be shading to the right this time, but we're going to be using a closed dot or a closed circle. And that's because I'm going to be including 1 in my answer. So drawing my number line, I can put 1 in the middle. On the left side, I'm going to have 0 and -1. And on the right side, I'm going to have 2 and 3. So what I'm going to do is I'm going to change my color to blue. I'm going to put a closed dot on the +1. That means I'm going to have to shade this dot in because it's closed. That means I'm including this 1 in my answer. And then I have to shade to the right because this arrow is pointing rightwards. So I'm going to shade to the right. Okay, let's do 2 more examples. Let's try number 3. So number 3 says I have 7. And then on the inside of the parentheses, I'm going to have 3n plus 7. And I'm going to close it up. It's going to be less than or equal to 133. So for this one, the first thing that I would do is I would do the distributive property. So I'm going to change my color to red, And what I'm going to do is I'm going to multiply everything on the inside by this 7 on the outside. If I multiply 7 by 3n, I'm going to get 21n. And then if I multiply 7 times 7, I should get 49. So now I've done that. To get n by itself, I'm going to need to get rid of the 49 and the 21. I can subtract 49 from both sides now. So that way, I'll have a positive 49 minus 49. That's going to give me 0. So these are going to cross out, only leaving me with a 21n on this side. And I bring down my less than or equal to symbol. Over here, I'm going to have 133 minus 49. I can put this in a calculator, or I can do this thing that I learned in elementary school where you make this into a 13. 13 minus 9 is 4. You can make this into a 2, which actually makes it a 12. 12 minus 4 is 8. And then lastly, this 1 is going to become a 0. Okay. So now the only thing that I have left to do is get rid of this 21 that's out in front. I can do that by dividing both sides by 21. And that's going to divide evenly into 84. So now the 21s will cancel out, leaving me with an n. I'm going to bring down my less than or equal to symbol. I'm only dividing by a positive 21 on this side. So since I'm dividing by a positive number, there's no need to switch the inequality sign. 84 divided by 21 is going to give me a positive 4. So inside my solution set, I'm going to have all the real numbers in, such that n is less than or equal to 4. What this means is 4 is actually going to be a part of my solution set, because it could be less than or equal to 4. But since it's less than, I'm going to have to shade to the left. So not only am I going to shade left, but I'm going to have a closed dot on the 4. So I can put the 3 right here, a 2 right here maybe, and then a 5 and a 6 over here. And I'm going to change my color to green. So I can put a closed dot on the 4. Make sure you shade in that closed dot. That's what it means to be closed. It's shaded in. And then since this arrow is pointing to the left, I need to shade to the left. So it's going to look like this. So this means 4 could be an answer, but also any number that's less than 4, like 2 or 3, could be answers. Okay, we're going to do one more. Number 4. So 4 says we have negative x plus x is less than -7. So the first thing that I can do is notice that these are actually like terms. They both end with an X. I can put them together. -x plus x is going to give me 0. Another way you can think about this is there is actually a 1 out in front of this x, which means there's actually a -1 out in front of this x. And then 1 plus -1 is going to give me 0x, which is just 0. So I combine my like terms, I get 0, bring down the less than symbol that you found up here, and then -7 is going to stay the same for now. So I don't really have an answer for this. The only thing that I get is 0 is less than -7. Is this true? The answer is no. 0 is not less than -7. -7 is much less than 0. So this is actually a false statement. Whenever you get a false statement, you're going to write no solution. And since there's no solution, we can't graph it on a number line. So we would just write no solution. But let's say we got something different. Let's say we got 0 is greater than -7. Would that be true? Yes, that would be true. So if we get a true statement, what do we write? We write all real numbers. So sometimes you might run into these two situations where you could get a false answer. In that case, you would write no solution. But sometimes you might get a true statement. In that case, all real numbers would satisfy this inequality. Okay, so what's going to be due on Sunday? You're going to have 2 assignments. You're going to have your one-step inequalities from Monday. And you're going to have your multi-step inequalities today, Wednesday. So let me show you where to find both of these. So for your multi-step inequalities, you're going to go to the modules on Canvas. Under week 14, you will see under Friday, we have the one-step inequalities classwork up here. And down here, you have the multi-step inequalities. You're going to click on that. I don't have the video up yet, but I will soon. You're going to see this. You can click the blue link or click the down arrow. I'm going to click the download arrow. And then when you open it up, it'll look like this. And you're going to be doing 1 through 11.